All right, page number 2. If there are about 5 times 10 to the 9th galaxies, and every galaxy has 1.5 times 10 to the 9th stars, how many stars are in the universe? So hopefully you recognize that this is a multiplication problem. We have this number of galaxies. Every galaxy has that number of stars. So what we're going to do is 5 times 10 to the 9th. And we're going to multiply that by 1.5 times 10 to the 9th. Okay, we're multiplying, which means it doesn't matter if the exponents are the same or not, although in this case the exponents happen to be the same. So what we do is, okay, multiply the numbers first, right? So what is 5 times 1.5? And if you do your math right, I think you should wind up with 7.5. All right, well, what's 10 to the 9th times 10 to the 9th? It's 10 to the 18th, so this is just going to be 7.5 times 10 to the 18th power. There's the answer for number 9. What is the vertex of x plus 3 squared plus 4? Hopefully this is a problem you can get really quick. We've gone over problems like this in class many times. So if it's x plus 3, that means there's going to be a shift of 3 to the left, and it's going to go up 4. That's where the vertex is going to be, -3, 4. Yeah, hopefully you can look at a problem like that and hammer it out really quickly. All right, write a function rule for the graph x equals or y equals x to the third that is translated down 4 units and right 5 units. Okay, so that means the inflection point, if it's translated 5 units to the right and 4 units down, is 5, -4. Now that's not what they're asking for, but that's going to be the inflection point of this function. And so to write the function out now, all we need to do is say, okay, well, it's going to be y equals x minus 5, right? If you're going 5 to the right, it's going to be x minus 5 squared. And then we're going down 4, so we just subtract 4. And again, hopefully this is the kind of problem that you can do easily, as long as you just recognize what it's asking you to do. It's this graph, 5 units to the right and 4 down. Okay, number 12. Given that y equals 5 to the third x, state the following: the growth rate and the growth factor. So let's start with the growth factor because that's the easy one. I can just look at that number and say 3. That's the growth factor. For the growth rate, you have to remember that these functions follow this rule. I'm going to call it y equals a, which is this number out here, in this case 5, r plus 1 to the, in this case we're going to say x, sometimes they use t. Okay, and you have to look, so this is the growth rate function. You have to know this. In this case, the a is just that number out there, 5, but what we're worried about here is this. We know that the growth rate plus 1 equals 3. So all we have to do is solve that for r, which is not going to be too bad, right? If r plus 1 equals 3, then r equals 2. And then all we need to do is just change that 2 into percentage. So instead of 2, we could write 200%, right? Because that's 2 as a percentage, 200%. Okay, next one, a short word problem. We've got bacteria. Initially has 500, doubles in size every day. Write an exponential function like this, modeling the size of culture after d days. So d is going to be our variable, and it's not too bad. I'm gonna call this f of d. What did we start with? 500. What is it doing? It's doubling in size. That's the growth factor. So let's just 500 times 2 to the d. Not a whole lot of math for that problem. Like, as long as you understand what it's asking you for, hopefully this is a problem you could do relatively quickly. This one might take a little bit longer because, okay, how much bacteria is present after 10 days? So now we have to figure out what this is. You know, what's 500 times 2 to the 10th? Ooh, 2 to the 10th power. 2 to the 10th power is 1024. And so all we have to do to finish the problem is multiply 5 times 1024. And if we do that correctly, you should get 512,000 and bacteria. So that's the answer for B. I guess I'll write bacteria underneath here. Bacteria. Okay. Last problem. We've got a quadratic function here. We've got a parabola. We want to write the equation of the graph function. Okay, all we need to worry about is, or maybe not all, but what we need to focus on most is this vertex. Where does it bottom out? That's what you want to know. If you have the vertex, you can get the function pretty easily. And this is 2 minus 4. That's the vertex. And if that's the vertex, the function is just going to be y equals x minus 2 squared minus 4. And again, for problems like this, I think that the trickiest part, sorry, I drew my minus sign a little bit too close to my 2. I think the trickiest part is knowing that, so you don't change the sign here, like that just stays minus 4. But you do need to change the sign for this one. It has to be x minus 2, not x plus 2. I think that's where a lot of people mess up. And this is really not that different from 11. It's the same kind of thing. We just found the inflection point and then wrote the function. Oh, I messed up. I'm glad I came back up here because some of you hopefully caught that. This would be to the third. I wrote squared. So there you go. Hopefully you guys caught that. That's why it's good to check your work. I messed that one up. Hopefully you watched the end of the video and saw that.